Hello there and welcome to our morning lesson. Our previous lesson was a continuation of financial mathematics, and we were looking at how to calculate the best prices when one goes to the market to buy some items. We needed to know some techniques that we could apply so that we get the best prices and we increase our savings amount. In this lesson, we want to look at another item still in financial mathematics by the title Simple Interest. Now, this simple interest comes in two ways. This is an amount that is earned after making some investment, or it can be an amount that one will pay after acquiring a loan. So, in a nutshell, we can say that simple interest is a type of interest that is paid on a loan or earned on an investment, which is always calculated on the principal amount. This is a type of interest. This is a type of interest that is paid on a loan or earned on some investments. Which is always calculated on the principal amount. When we talk about the principal amount, we are basically talking about that amount that one will borrow from a financial institution as a loan, or it can be that amount that is invested so that one can earn something more. So that is what we referred to as the principal amount. We have a formula that guides us in calculating simple interests. The formula for simple interest is interest should be equal to the product of the principal amount multiplied by the rate and the period. We have these variables in the formula that we are going to explain so that we get to understand what each and every component of this formula means. Where the first one is the principal. The principal amount. This principal amount is denoted by the letter P. Principal amount is denoted by the letter P. And it is basically the amount that is borrowed or invested. The principal amount means that amount that is borrowed or invested. Let us move on and look at the other components of the formula. The next one that I would like us to look at is the rate of interest. The rate of interest is denoted by the letter R. And this is the annual percentage rate of interest. The annual percentage rate of interest. The annual percentage rate of interest, and you can have an example of such a rate as 3% per annum. 3% per annum. The next variable we are looking at is the period, the time period, which is denoted by the letter N. And this time period is usually the number of years. This refers to the number of years within which a loan that has been borrowed should have been repaid, or an investment should have been recovered. This refers to the number of years the time or period. So you will discover that when we are talking about the period, this duration should be expressed yearly in terms of years. If you are given months, you need to ensure that your period is expressed in terms of years. So if you are given just a few months, not a whole year or years, then you will express it as a fraction of a year for you to effect the simple interest formula. And lastly, we look at the interest, which is denoted by the capital letter I, the interest. The interest is the amount that is accrued over a given period of time. That amount of interest that is accrued over a given period of time is what we are referring to as the interest. Having looked at all the components of the simple interest formula, there are two things that we are supposed to take note of. After an interest has been accrued and it reaches a repayment time, remember that principal amount plus the interest should be given back. If it is a loan, the person who borrowed the loan should give back the principal plus the interest. That is one of the things. So we can say total amount paid at the end of the duration should be equal to the amount borrowed in the case of a loan, and if we are talking about an investment, then it will be the amount invested plus the interest. That is one thing. The second thing I had already mentioned is that when you are calculating the simple interest, your time or period should always be expressed annually. The period N should always expressed annually. Or yearly. We can look at a few examples on how to express or how to convert from months to years, quarters to years, and even weeks to years. Examples. Copy and complete. Number 1. "12 months are equal to dash years." 12 months are equal to how many years? We know that a year has 12 months. So it means in this case, our 12 months will be equal to 1 year. 12 months will be equal to 1 year. Our second example is a half. A half year is equal to how many months? If at all one year has 12 months, then a half a year automatically will have 6 months. Will have 6 months. The third example, dash weeks are equal to 1 year. We remember even in our previous lessons, we have been looking at some calculations that involved the number of weeks in a year. How many weeks make up a single year? These are 52 weeks. Our fourth example, how many quarters make up a year? The term quarter we have already interacted with it even when we were looking at fractions. A whole unit, when it is divided into 4 equal parts, each part is equal to a quarter. Each part is referred to as a quarter. This is 1 quarter, this is another quarter, this is another quarter, and that is another quarter. So we have 4 quarters. When you add up 4 quarters, you get 1. So 4 quarters will give us a single year. 4 quarters will give us a single year. And if 4 quarters are equal to 1 year, then help me to answer this question, that 1 quarter has how many months? 1 quarter will be equal to how many months? Remember, a year has 12 months. And if we are going to divide those 12 months into 4 quarters, then you'll discover that a quarter of a year will be made up of 3 months, such that when you multiply 3 months by 4, then you will get 12 months in a year. So a quarter of a year will give us 3 months. And lastly, you can look at this, number 6, 2.5 years will give us how many months? 2.5 years will give us how many months? We have already learned that a single year has 12 months. What about 2.5 years? You will try to fill in that particular gap. We have defined simple interest. We have looked at the formula that guides simple interest calculations. We have looked at the various items or variables in the simple interest formula. We have looked at conversion of periods or durations. And now I want us to move on and look at how to use the simple interest formula in actual calculations. How to use the simple interest formula. To help us understand the application of this formula, we are going to use examples for us to internalize the formula. The first example number 1, it is a question in which we are required to use the simple interest formula. Use the simple interest. Use the simple interest formula to find the interest when $600 is invested at a rate of 8% per annum or per year for 18 months. we have been instructed to use the simple interest formula to calculate the interest, given that a principal of $600 is invested at a rate of 8% per year for 18 months. In this case, we are supposed to do several things. We need to identify those components of the simple interest formula that are provided for. Then we write down our formula, after which we'll substitute those variables into the formula for us to calculate the simple interest. When we look at this question, this is the principal amount. The principal amount is $600. The rate is 8%. This 8%, before we use it, we are supposed to convert it to a fraction or a decimal before we use it for calculation. And we have already looked at how to convert percentages into fractions or decimals. This will be 8 out of 100, and which can be equal to 0.08. Another thing that we are provided with is the duration of the period. This is 18 months. The 18 months, we agreed that before we use it in the simple interest formula, we must make sure that our period is expressed in years. So 18 months, how many years are those ones? For us to know the number of years presented here, we will divide 18 months by 12 months. This will give us 1.5 or 1.5 years. 1.5 years. The next thing we are supposed to do is to write down our simple interest formula, where we have interest is equal to the product of the principal, the rate, and the period. The principal we are given is $600. The rate we have is 8 out of 100. And then the period we have 1.5 or 1.5. 1.5. This and this will cancel this and this. So we'll have the product of 6, 8, and 1.5. And when we do that, we will have a simple interest equivalent to $72. Our simple interest is equal to $72. Let us look at another example. We use the simple interest formula to calculate the annual interest rate. The annual interest rate when $5,000 earns 150 interest in 2 years. Remember, in our first example, we were looking at how to calculate the simple interest itself. In this second example, we are required to calculate the annual interest rate. We have been given the principal, which is $5,000. The interest, the simple interest that this $5,000 will attract in 2 years, we are given as $150. We are also provided with a duration of 2 years. We are required to calculate the rate. So after identification of these simple interest formula variables, we go ahead and write down the formula itself. Simple interest is equal to the principal amount multiplied by the rate multiplied by the period. And then we substitute in what we have been provided with. The interest is $150. This should be equal to the product of the principal, which is $5,000, and the rate that we don't know. And this rate is supposed to be, initially we were expressing this rate as a fraction, which was by taking the rate out of 100. Then we multiplied by the duration, which is 2 years. So we want to calculate this rate. You discover that for us to achieve that, we are going to have $150 will be equal to 5,000 times 2, it will give us 10,000 multiplied by the rate. For us to get this rate, we divide all through by 10,000. So that this 10,000 will cancel with that, and our rate will be equal to 0.015, which is a decimal number. And remember, our rates should be expressed as percentages. So we need to express this as a percentage. And for us to express a given decimal number as a percentage, we basically multiply that number by 100%. So we are saying that the rates should or ought to be expressed as a percentage. And this rate will be equal to 0.015 times 100%, giving us 1.5% per annum. That is the rate. Or the simple interest rate is 1.5% per year. We have looked at the first example where we calculated the simple interest itself. In the second example, we have calculated the rate of interest. We now want to move on and look at our third example where we'll be required to calculate the principal. How much interest will Giorgio How much interest will Jojo receive if he invests $7,000 in stock? At a rate of 3.6 per year, simple interest. For 4 years. In this third example, we are looking at someone called Jojo who is going to invest $7,000 in stock for a duration of 4 years at a rate of 3.6 per year, simple interest. We want to know how much will this person earn after 4 years. In the previous examples, we have been looking at loans. Now we want to look at investment. This example is centered on investment. We have learned that the simple interest formula applies in both cases. And as we have just done in the previous two examples, we need to identify those variables that have been provided. The principal provided is $7,000. The rate we are given is 3.6% per year, which is equivalent to 3.6 out of 100 expressed as a fraction. And the period is 4 years. Having identified the variables, we write down our formula, then we substitute in the variables. This interest will be equal to the product of 7,000 multiplied by 3.6 out of 100 multiplied by 4, which is the period. The two zeros will cancel out, leaving us with the interest as the product of $70 multiplied by 3.6 multiplied by 4, and this will give us 1,008. Will give us $1,008 as our simple interest that will have been accrued over a period of 4 years. I'm calling them variables because all of them tend to vary. If you change one of the variables, you'll discover that you will get a different figure as either the interest, the principal, the rate, or even the duration. Let us move on and look at another example. I will call it number 3. Greatest interest payment on her loan totaled to $1,875. That is $1,875. If the interest rate was 5% per annum, and the loan had a life of 5 years, what amount did she borrow? What amount did she borrow? In this third example, we have a lady whose interest accrued is at $1,875. And the rate of simple interest we are provided with is 5% per year. The period through which that interest was accrued is 5 years. We are asked to calculate the amount that she borrowed. So we are going to identify the components of the simple interest formula that we have been provided with before we calculate the amount that was borrowed. And this amount that was borrowed, we are referring to the principal amount. So the interest accrued is $1,875. The rate at which this interest accrued was 5% per year, and this is the same as 5 out of 100 if we express it as a fraction, but we have not simplified. There is no need to simplify that. We can just use it the way it is. The period is 5 years. We go ahead and write down our simple interest formula. Interest is equal to the product of the principal, the rate, and the period. We've been given the interest as $1,875. The principal amount that was borrowed, we've not been provided with. That is what we are going to calculate. The rate is 5 out of 100. And the period is 5 years. So this, when we try to simplify the right-hand side of this equation, we will have 5 times 5, we will get 25 out of 100 multiplied by the principal. Multiplied by the principal. We want to get the principal amount. What do? We multiply each side of the equation by the reciprocal of 25 out of 100 so that we eliminate, we get rid of this particular fraction on the right hand side. And in so doing, we'll remain with the letter P, which stands for the principal that we are looking for. So the reciprocal of 25 out of 100 is 100 out of 25. We multiply on both sides. So we'll discover that this 100 and this 100 will cancel, and this 25 and this will cancel, leaving us with P being equal to the product of 100 multiplied by 18, $75 divided by 25. This will give us a principal amount of $7,500. This is the amount that the lady borrowed for a period of 5 years at a rate of 5% per year, and the amount attracted an interest of $1,875 in that period. One last example. Jonathan wishes to invest $3,000 at a rate of 8% per year. How long will he need to invest for his total investment to double? We have Jonathan, who wishes to invest $3,000 at a rate of 8% per year. How long will he need to invest for his total investment to double? This is a question that requires us to calculate the period denoted by the letter N. For the investment to double, remember the investment is the principal amount, which is 3,000. For it to double, it means that he should have accrued an interest equivalent to the principal amount, so that by the time he is repaid back, the total amount paid, that is the sum of the principal amount and the interest, will be double 3,000, which is $6,000. So let us look at what we've been provided with. We have the principal, which is $3,000. We have been provided by the rate, which is 8%. This is 8 out of 100. We have not been provided by the period. That is what we are going to calculate. But we have learned that the interest, for this principal to double, the interest should also be, the interest accrued should be the same as the principal, that is 3,000. So the interest will be 3,000. So we want to know how long will it take for his investment to double. We go ahead and write down our simple interest formula. The interest we have by the end of the period that we don't know is $3,000. The principal amount invested is $3,000. The rate we've been given is 8 out of 100. And we are calculating the period denoted by N. These two zeros will cancel with the two zeros. We will have 3,000, which is the interest accrued, being equal to 240 multiplied by N. So we have $3,000 as the interest. This other side we have 240 multiplied by N. For us to get to the period, we divide both sides by 240. 240. This and this one will cancel. So our N will be equal to 3,000 divided by 240. This will give us 12.5, which is 12.5 years. So for the investment, for his investment to double, Jonathan will need a period of 12.5 years for the principal amount of $3,000 to double to $6,000. This will be the period. So having looked at the several examples in which we have tried to calculate the interest, we have tried to calculate the principal, we have calculated the rate, and we have lastly calculated the period. I hope we now understand what simple interest is, and we also understand the simple interest formula, and we are able to apply that particular formula in calculating various components of the formula. Let me now give you an assignment, just 2 questions that will help you during revision. The first question an investment of $15,000 receives an interest payment, an interest payment over 3 years of $7,200. What was the rate of simple interest? What was the rate of simple interest? Per annum. The second question, Jacob wishes to invest some money for 5 years. At a rate of 4.5% per year. paid yearly. If he wishes to receive 3,000 in interest, in interest payments per year, how much should he invest? How much should he invest? We have the two questions. I hope you have enjoyed my lesson and you are going to utilize these questions in your revisions to see whether you have understood the simple interest concept. In my next lesson, we will be looking at how to calculate repayments in simple interest. A very interesting lesson you can't afford to miss. Welcome and thank you.